All right, so let's talk about another element on the periodic table. What am I going to talk about today? Today I'm going to talk about the darling of the semiconductor industry, and that's silicon, right? So this is really important for computers and tablets, just like this iPad right here has silicon all over it. Silicon's the most abundant element in the Earth's crust, and it accounts for about 28% of the Earth's crust by mass. So that means it's pretty readily available. Now, most of the silicon on Earth is in the form of silicates, such as silicon dioxide. We see that very readily in quartz and sand. That's very common as well. Silicon is atomic number 14, and its atomic mass is 28.084. There are multiple isotopes, so 28.086 as well. And its electron configuration in the third period, so it's got the electron configuration of neon plus the 3s2, 3p2 orbitals as well. Now, silicon is also on the periodic table. It's in the same period with it's group 14, so the same group with carbon. So carbon's up here, silicon's right underneath it. That means that both of these elements will form 4 bonds, right? And so being able to form 4 bonds, they'll bond fairly readily. You can get silicon dioxide, of course, O2, that's 2 double bonds in there. Silicon actually forms a kind of a matrix with other things as well. So that's also very common. But silicon bonds are not quite as strong, and that's due to poorer pi bonding in the Si-Si bonds. So that it's not quite as versatile there, but it makes it an excellent semiconductor, and that means that silicon can conduct electricity, and it can also, it's got variable electrical conductivity, which is very important for computer chips when you have to turn circuits on and off, right? So that becomes very important right there. And so that's why we see this all throughout computer chips and transistors, integrated circuits. This iPad literally has silicon all over it in this computer chips inside, and also in the glass right on top of the iPad as well, right? And so, in chemistry, doing computational experiments, we refer to in silico. And if we do an experiment in a test tube, we say that's in vitro. But in a test tube that's glass, in vitro is related to in silico, right? Because glass is also silicon, but it is still 2 different things.